Hello everyone, Marco Chiappetta for Hot Hardware here. Welcome back to the channel. I am sitting in front of a pile of boxes, and if you're a regular around here, you know what that means. So sitting out at the front of the table, I have a couple of Intel Xeon W processors. What you see here is the Xeon W72495X and the W93495X. Now, these two guys represent the top-of-the-line 56-core processor in the lineup and a more mainstream 24-core processor. But to test these guys out, I need a whole new platform, new motherboard, new memory, you name it. So that's what's on the table in front of me right now. So starting off to my right, this is the Enermax Starryknight SK30 mid-tower. So this is the case we're going to use to house all this hardware. I haven't done any test fitting, so we're going to find out together whether or not it all fits properly. And out in front of that, we have the ASUS W790-ACE motherboard. So this board's based on Intel's W790 chipset for Xeon W, but it is not ASUS's top-of-the-line board for these processors. That designation is reserved for the Stage, but still very high-end workstation class board. Out in front of that, we have some memory. So this platform doesn't use standard DDR5 like consumer platforms do. This platform requires RDIMMs. So what we have here is a G.Skill Zeta R5 memory kit. It's a 64 gig quad channel kit with RDIMMs included. Should work well. And now off to the left, we have a couple of more Enermax products. We have an Enermax Revolution DF2 1200 watt power supply. Should be more than enough juice for all this hardware. And to cool the processors, another Enermax product. This is the Enermax LIQTECH 360 OC TR4 Absolute mouthful, but this is a 360 millimeter all-in-one cooler that should work well for these processors. And for storage duties, we have what is arguably the best SSD on the market right now. This is the Crucial T700. Now, this is a top-of-the-line PCIe Gen 5 M.2 SSD. Now, in this platform, it's going to run at Gen 4 speeds, but that's really only going to affect sequentials. I don't really mind. Should work great. Pushing the pixels for this build, I have an equally high-end workstation class graphics card. So what you see here, this is AMD's Radeon Pro W7900. This is the company's absolute top-of-the-line workstation class GPU. It's packing an RDNA 3 graphics processor with 48 gigs of memory. Absolute beast of a workstation class graphics card. But in full disclosure, we're just using it for the build because it fits well with all this workstation class hardware. When we do the actual CPU review, we'll be using a variety of different graphics cards. But this guy is going to work well for this build in this video, so we're going to run with it. And with all that out of the way, I think I'm going to get all this stuff unboxed, get started with the build. Okay, I think that's everything. So we have the Enermax case, ASUS motherboard, GPU, G.Skill memory, M.2 SSD, power supply, the processors, the cooler, fans, and some assorted hardware. Now, if you've seen me build a system on the channel before, you know I like to follow a certain procedure. I like to put the CPU, memory, and storage into the motherboard first, then put that into the case, followed by the other hardware, and then the power supply and all its assorted cables. Now, I have to follow a slightly different procedure here because of how the Xeon W gets installed into its socket. So what you're supposed to do is install the processor into one of these brackets, and then this bracket gets attached to the cooler. Then the whole cooler assembly gets mounted to the motherboard and socket, and then that goes into the case. That's going to be a little too unwieldy for me, so I'm going to break script and kind of do my own thing and hope that it works. So I'm going to start by installing just the memory and storage into the motherboard. So let me get up close and personal, and we'll do that next. Before we do any actual installing, let's just take a closer look at the motherboard, memory, and SSD. As I mentioned, this is the ASUS Pro WS W790-ACE. This is part of ASUS's Pro series of workstation class motherboards. This guy's built around the Intel W790 chipset for the Xeon W, but as configured on the ACE, it only uses a quad-channel memory setup. The Xeon W supports 8-channel memory configs, but you'll need the Sage, the higher-end version of this board, to take advantage of that feature. So this guy's also packing a 12+1+1 power design. It supports redundant power supplies. There's secondary ports here, but I'm going to leave those covered up because I'm not going to use that feature. We also have a couple of M.2 slots with heat spreaders. You have heat sinks on the chipset, nice big heat sink in the VRM as well. All of the PCI Express X16 slots are metal reinforced, and a couple of these slots support PCIe Gen 5 as well. You have 10 gig and 2.5 gig Ethernet, USB-C 3.2, 2x2, USB-C front and back, basically high-end board through and through. You name the feature, this guy's got it. Right next to it, we have the quad-channel G.Skill Zeta R5 memory setup. So these are four 16 gig RDIMMs for the Xeon W. These run at DDR5 6400 speeds. And right at the top here, we have the crucial T700 SSD. So this is basically the fastest Phison-based Gen 5 SSD on the market right now. Stop by Hot Hardware for a full review of this guy. All right, up first, let's get this memory and SSD installed. I've taken the liberty of removing these two screws. Obviously, the first step is to remove this protective covering. And we also have to get this sticker off of the DIMM slots. This sticker is just explaining which connectors to use if you're gonna use dual redundant power supplies. So the SSD is just going to slot right in. This motherboard is toolless in terms of the SSD locking into its slot. And then we will pop the memory in. So slot 1 for each of the channels, it's the outermost DIMM slots on this board. You're going to use every other slot. And then finally, just reinstall the heat spreader. Next up, we're just going to get the motherboard mounted in the case. It turns out all of these standoffs are in the correct position and were pre-installed, so that is a nice big help. Just going to slide this in and line it up with the standoffs. And I have 9 screws to install. I'm just going to kill the camera while I do that. All right, the motherboard with memory and SSD is mounted into the case. That was as smooth as could be. And now I'm going to move on to the cooler. But first, I want to show you the CPU assembly. So this little plastic tray is actually included with the motherboard. It just snaps right onto the processor. Now, normally you'd put the CPU right into the socket and mount the cooler, but that's not how it works with the Xeon W. So this whole assembly is actually supposed to get pasted and mounted to this first. This is the cold plate on the cooler. And then this whole assembly is what gets mounted to the socket. But first, I want to get the radiator mounted to the chassis. The plan is to mount the 360mm radiator at the top of the chassis here, but I can already tell this fan is going to get in the way, so I'm going to slide this down as far as I can first. Well, Enermax made that as easy as possible. This fan is actually on rails. I just had to loosen the 4 screws and slide it down. So up next, I'm going to mount the fans to the radiator and then get the radiator mounted to the top of the chassis. Okay, fans are mounted to the radiator. Now to get this mounted to the chassis. Okay, pretty uneventful so far. That went in without a hitch. Now to figure out this CPU situation. All right, so this is a bit precarious, but it is what it is. So all I had to do to remove the protector from the socket was unscrew a couple of plastic nuts, and the protector just lifted right off. So now the next step I'm going to do is drop the CPU all the way into the socket. I'm going to be careful to line up the triangles in the corners. And then once this is seated properly, I'm going to secure the cooler right on top. Next up is the always controversial application of thermal paste. I'm actually going to just dab this on the center and then spread it around in an even thin layer with my finger wrapped in a piece of plastic here. Now, we're going to be swapping CPUs in and out of this rig, so I'm not going to test for the perfect contact patch. I've done this a million times. This should be more than adequate. The goal is to just have the thinnest application possible to fill in any air gaps. You do not want to have a huge goopy layer of thermal paste here. Okay, quick progress report. This side of the chassis is looking good, pretty uneventful so far. Everything is going together properly, but I can't say the same for the other side of the chassis. The back side of the motherboard tray is an absolutely disastrous mess of cables. I think for my own sanity, I'm going to spend a little time organizing all of this, figuring out where I'm going to route it through the holes in the case, and then come back once I have this cleaned up. Okay, not perfect, but worlds better. I organized all of the fan cables, all of the RGB cables, the front panel cables, and I routed them in such a way that they won't be visible from the front side of the system. And I think it's time to move on to the power supply next. The 1200 watt Enermax Revolution DF2 power supply we're using for this build is fully modular. So I've taken a look at all the components in the system and counted up all of the power connections that I'm going to need. And then I gathered up all of the cables out of the power supply box. And I'm going to get this mounted and just get all the cables dangling so I can figure out where to route them. Okay, the PSU is in, and we should have plenty of room at the bottom of this case to hide all the excess cable. Next up, let's install the GPU and get all this connected up. So all of the wiring is done, and I have everything tied down and neatened up on the back side of the board, but I did come across one problem that I had to work around. This Enermax Revolution DF2 power supply only offers a single 12-volt feed for the CPU, but this motherboard requires two. There's a connector up in this corner and another one up in this corner. Now, many motherboards will boot with a single 12-volt feed, but this one will not. Now, fortunately, I've been building systems long enough that I had an adapter on hand, so I converted a Molex connector to a 12-volt CPU connector, got everything wired up, and I think I'm ready to turn the system on. Okay, I've killed all of the ambient light. I'm going to hit the power button and see what happens. Yes, and bingo, she's alive. Awesome. Looks like all of the fans are spinning and the RGB is doing its thing. I should point out a cool feature on this case too. The reset switch is actually wired to the RGB controller. So if I hit the reset button, it actually changes the lighting. Okay, and with that, I think I'm going to wrap things up. Next steps are going to be flashing the latest BIOS to the motherboard and whatever the latest firmwares are for the SSD and other parts in the system. And of course, installing Windows, all of the latest drivers, and benchmarking the system. I hope you've enjoyed coming along this ride, building this awesome Xeon W rig with parts from Intel, ASUS, G.Skill, Crucial, and of course, Enermax. Stop by hothardware.com for the full review of these Xeon W processors. And with that, I will catch you in the next one.